Hello subscriber, today our topic is mesh current method. The mesh current method is quite similar to the branch current method in that it uses the simultaneous equation of a Kirchhoff's voltage law, and the Ohm's law to determine the unknown current in a network. It differs from a branch current method in that it does not use the Kirchhoff's current law, and it is usually able to solve the circuit with a less unknown variable and the less symmetrical equation, which is especially nice if you are forced to solve without a calculator. Let's see how the method works on the same example problems. R1 is a 4 ohms resistance, B1 is a battery 1 have a 30 volt resistance, a 30 volt energy generating energy, and R2 is a 2 ohm resistance and R3 is a 1 ohm resistance, and the 7 volt other one battery is a 7 volt battery. This is the last previous circuit we have discussed in a branch current, but branch and the mesh current is usually same but have some different example. A working principle is different. The first step in the mesh current method is to identify the loops with the circuit encompassing all the component. In our example circuit, the loop forwarding by a B1, R1 and R2. B1 means battery 1, whichever shown in a pictorial, a 28 volt, and R1 is the resistance 1 and R2 means resistance 2 will be the first while the loop forwarding by a B2 to R2. First loop over is a battery 2 and R2 means resistance 2, and R3 will be the second. R3 is a second circuit. The straight part of a mesh current method is investing the circulating current in each of the loop. In fact, this means it will be clearly defined that the branch current have the current running in the branches, but mesh current is which device is how it does to be consumed the power. Idea of these current meshing together between the loops like sets of spinning gears means the idea of a meshing current is like as a loop and the set of a spinning gears means one gear run then move to the other gears, just like a gearbox working like as a gearbox to complete the loop. And here is a B1 R2, it's in the same circuit, R2 R3 B2. In the middle here shows I1 and I2 means current of a one circuit and current of a two circuit. The choice of each current's direction is entirely arbitrary, just as in a branch current method, but the resulting equations are easy to solve if the current are going the same direction through the intersecting components. Means current is intersecting to each other, means current is depend upon one device is depend upon second one, second is third one. Note how the current I2 and I1 means current 1 and current 2. Circuit of a current 1 and circuit of current 2 are the both going up through a resistor R2 resistance 2 where the mesh are a intersect. R2 has a mesh current and intersecting them. If the assuming the direction of a mesh current is wrong, the answer for the current will have a negative value. If the mesh current going to the wrong, then we have got the negative current. The next step is to label all the voltage drop polarity across the resistors according to the assumed direction of a mesh current. Remember that the upstream end of the resistors will always be negative and the downstream end of a resistor positive with respect to each other since the electrons are negatively charged. The battery polarity, of course, are indicated by their symbols. Battery are already discussed in B1, B2, this, and also its polarity will be shows. Orientation in a diagram and may or may not agree with the resistor's polarity. Assume the current direction using the Kirchhoff's voltage law. We can now step around each of these. Loops generating equation representing of a component voltage drops in the polarity. As with the branch current method, we will denote a resistor voltage drops as the product of a resistance in the ohm or its respective mesh current, that quantity being unknown at this point. Where two current mesh together, we will write that terms in the equation with a resistor current being the sum of a two mesh current tracing the left loop of the circuit starting from the upper left corner and moving counterclockwise. The choice of a starting point and direction is ultimately irrelative. Counting polarity as if we had a voltmeter in a hand. Red leads on the point ahead and the black lead on the point behind. We get this equation minus negative sign 28 plus 2 I1 plus I2 plus 4I1 is equal to 0. Average have a 0. Notice that the middle from terms of equation uses the sum. Notice that the middle term of the equation uses the sum of mesh current I1 and I2 as a current through the resistors R2. This is because mesh current I1 and I2 are going the same direction through the R2 and thus complements each other distributing the through the R1. Thus the component each other distribution within a coefficient of a 2 to the I 1 and I2 terms are the compounding I1 terms in the equation. We can simplify as such: 38 to 28 plus 1 I1 and I2 for t is equal to 0. Distributing the terms within the parameters. Simplified form of equation is a minus 28 plus 6 to 8 and 2a2 is equal to 0. Thanks for watching my video. Please subscribe my channel. Still not subscribed. Keep support me. To watch this like video or any confusion about the electricity, I will be clear you in the next lecture. If you have a question, please comment below of this video. I will provide the video or clear your confusion. Thanks for watching and keep support me.